Hello, algebra students. Today we're looking at section 6.10, inverse functions. So the best way I think to really explain what inverse functions are is just look at an example. So we have here a function, and this one is given in the form of ordered pairs. So we don't have a rule to generate the output values. We just are given the output values for each input value. So for example, we have this first pair, 0, -1. So for an input value of 0, you get an output value of -1, and so on. For each input value, it's paired with its output value. Okay, and this function just has these 4 pairs, and the function is graphed down below. So each of those points is graphed. For example, 0, -1 is right there, right? Okay, so the inverse of that function is given over here on the right, and all it is each of the input values in the function, in the original function, becomes the output value, and the one that was the output value becomes the input value. They just switch places. Okay, so where 0 as an input gave you -1 as an output, in the inverse function, it's the -1 as the input that gives you 0 as the output. And for each point, it's the same. We'll just look at one more in detail. You have an input of 2, you have an output of 0. But on the inverse function, it's an input of 0. Gives an output of 2. They just switch roles. Okay? And that's the inverse of function 1. Now I think I misspoke a little bit. I called that the inverse function. It's correct to call it the inverse of function 1. So why is that distinction important? Well, this set of ordered pairs on the right here, it is the inverse of function 1, but it's not really correct to necessarily call it an inverse function, because that would imply it is a function, and it doesn't have to be. So we'll often ask the question, is the inverse a function? Okay, and remember what's required for it to be a function. For each input value, there can only be one output value. So we have function 1, and if we look at the x's, none of the x's repeats. So 0 is paired with -1, but 0 does not show up again and to be paired with something else. So, and none of the x values show up a second time to be paired with something else. So that's a function. Once you take the inverse of that, it may or may not be a function. So this one, in fact, if we look at this inverse, the inverse of function 1, we see there's none of those x values repeats, and so it is a function. Now what if in the original function, that's the one on the left, what if a y value repeated somewhere in there? That would not make it not a function. It could still be a function as long as no x values repeat. A y value might repeat, but then when you wrote the inverse of that y value that repeated would become an x value that repeats. It would not be a function. Okay, so this one is. Okay, so let's look at some examples using a rule, which is what we're more likely to see. We usually give functions like this. We don't list the ordered pairs. Instead, we say, okay, here's a rule. We put in some value for x. That's our input, and then the rule generates the output for that input. So we're asked to find the inverse. So we want a rule for this inverse function. And so I said it again, the inverse of the function, I should say. It may or may not turn out to be a function itself. Okay, so let's look at this first one. The way you do this is you first go ahead and use y in place of f of x. Just write it like that. All I did was rewrite it, but using y instead of f of x. Now we're going to switch x and y. Yeah, that kind of makes sense, right? We want to change the roles, and we want what was the input to be the output, and vice versa. So we just switch the variables. So where there's a y, we put x, and where there's an x, we put y. And we have now switched it, and now remember, x is always our input, so we would put a number in for x, and we would want to know what is y for that. That would be its output. And we could actually do that as this is written. We could put a number in for x and then solve for y. And we could put a different number in for x and then solve for y. But that's not a very practical way of doing things. Instead, what we do is we just solve this for y in terms of x. Okay, so let's do that. We want to get y by itself on the left side of the equation, or on one side of the equation. And that will be the inverse of our original function. So first thing in solving for y is to add 3 to both sides, and on the left that gives us x plus 3, and on the right when we add 3 to that, of course all we have is 4y. We got rid of the 3. So now we want to get y by itself. We divide both sides by 4, and to do that we need to divide each term on the left by 4. So divide each of those by 4, and of course divide this by 4. And now we get y on the right, and we have x over 4 plus 3 over 4. And that's it. We've solved for y. Now it's on the wrong side. We've switched these around. I'll go ahead and do that. All I'm doing here is switching it around. And now the last thing I'm going to do is show that this is the inverse of f. And the way we write that is we write f negative 1, f to the negative 1 of x. So our original function was called f, and the inverse of that is called f to the negative 1. And I'm just rewriting the rest of it. So that is the inverse of the function. Now we'll often ask, is it a function? Is the inverse a function? So we will ask that question. Is that, when we put in an x into this rule right here, do we get a unique y? Is there any time we would get two different values of y when putting in an x? And there's not. For each x, you're going to calculate that. It's just going to be one unique number. There's no way you can do this calculation again with the same x and somehow get a different number. It's not going to happen. So it is a function. Okay, let's look at the next one. So we write it with y first of all. Then we just swap the variables. Just be careful, but you literally just swap them. When you see y, you write x, and when you see x, you write y, and that's it. But now we just solve for y. So in this one, we first want to subtract 1 from both sides. So over on the left, we have x minus 1. On the right, when we subtract 1, it just leaves 3y, correct? So we're almost there. We now just have to divide both sides by 3. And again, that means dividing each of these terms on the left by 3. So you have x over 3 and minus 1 over 3 equals y. I'll turn that around, and at the same time I'm going to write this x over 3 in the other form. We can write that as 1/3 x. And that's a more common way to write these when you have a fraction times the variable. We'd rather just write it that way instead of writing it over 3. Okay, so that's it. I just rewrote it, and then I am going to write it with this notation: f to the minus 1 of x equals 1/3 x minus 1/3. And we'll ask ourselves, is this a function? And the answer is yes. You know, if you have just the typical kinds of algebraic expressions that we're used to, they're not going to generate two different values for the same number that you put in for x. Okay? You put in a number for x, you're going to get a value, but there's no way to get a different value with that same x. But we will always look at that and ask ourselves, is it a function? That's a common question to ask for these. Okay, so we have one more on this page, then we're going to bring up another page. Okay, so do the same thing on this one. Write it down with y first. And then we switch the variables. So we write x for y, and we put y for x, so it's y squared minus 1. Just switch them. And now we have to solve for y. So the first thing we do is add 1 to both sides. Gives us x plus 1 equals y squared. We're just about there, but now we need to solve for y, and it's squared. Okay, so the only thing we can do at this point, we take the square root of both sides. And so that gives us the square root of x plus 1. Equals y. And we'll usually turn that around. And when I turn it around, I'm also going to replace y with this notation, f to the minus 1. And I'm just putting that in for y at the same time that I move it over to the left and switch the location around the way we usually like to write these. So that's it. Okay. So we have over here a couple notes. First of all, we note this way of writing inverse, like we've been talking about. F to the negative 1 is what it looks like, and the way you might read it, F to the negative 1. It's kind of an odd convention because negative 1 means a lot of different things in different contexts. But in this context, it means the inverse. And you can also write y to the negative 1. It's another way of writing. These all mean inverse. And a couple real life examples here. Number 1, a Celsius to Fahrenheit, then Fahrenheit back to Celsius. So there's a formula, right? You've probably seen it for converting between these temperature scales. There's a formula for each. And so the formula that converts from Celsius to Fahrenheit is the inverse of the formula that converts from Fahrenheit to Celsius. The other example we have is this equation. It's the distance of an object falling due to Earth's gravity. But what if you wanted to find the time it takes for something to fall a certain distance? This formula, if you know the time, it will give you the distance. If we took the inverse of that, we'd have a formula that if you know the distance, it would give you the time. So that's an example of an inverse to a function. Okay, well, we got a couple more examples. So I'm going to save this and then bring up the other page. And I was just thinking, I did forget to erase this so we can work it out. So I'm going to go ahead and erase these real quick. You can freeze that and read the old one, and we're going to get the same answer. I just want to work it out as we're talking about it rather than just point things out. Okay. Whoops. It's always a little tedious the way this works. Okay, here we go. So this first one, we have a function f of x. We're going to write y in place of the f of x. Then we're going to just switch the x's and y's. So instead of y, we write x, and then wherever there was an x, we write y. And now solve that for y in terms of x. So this time we actually want to first multiply both sides by 4. So I'm going to, because we're going to use this for notes, I like to write each step out. Okay, multiply both sides by 4 is what I did there. So on the left we get our 4x, and on the right, as we intended, that cancels. Okay, so again we're still solving for y, so now we're going to add 1 to both sides. So we have 4x plus 1, and we have 2y. And last of all, divide both sides by 2. So that means divide each term by 2. Whoops. Write that a little better. Okay, just divided everything by 2 there. And so this gives us 2x plus a half equals, and this cancels as we wanted to, and we've got it there. Now that's it, but because we've solved for y, right? But we'll switch it around and put that on the left, and we'll change it from we don't want to write y, instead we'll write this inverse notation. And 2x plus 1/2. So all we did was move that to the other side, right? Okay. Just rewrote it with it over on the right. Okay. So that's the inverse. Okay, one more. You know the drill by now. Replace f of x with y. Switch the variables. You write it exactly the same. You just, where you have y, you write x in its place, and where you have x, you write y in its place. Don't do anything fancier than that. Now we're going to solve for y. First, subtract 1/2 from both sides. So on the left, that's x minus a half. On the right, it just leaves 2/3 y, and that's gone because we subtracted it. It's on the left now instead of the right. So now we have to get y by itself. When you have a fraction, the way to do this is the 2/3 we need to get rid of, right? So you may recall, multiply by the reciprocal. Multiply both sides by the reciprocal. So on the left, we have 2/3 times our x minus 1/2. On the right, I'll write it out front. Oh, not 2/3. Sorry, guys. 3/2. Erase that. Multiply by the reciprocal, not by the same number. You're waiting on me to see that. So the reciprocal of 2/3 is 3/2. You just flip it. So we multiply the left by 3/2, and we multiply the right by 3/2. And if you're not sure why, hopefully that is becoming clear. Because on the right, that cancels that fraction out completely, and all we're left with is y. On the left, we have to distribute the 3/2. So we have 3/2 times negative 1/2. You can always write that over to the side. Negative 1 has to go either numerator or denominator. Okay. So that gives us 3/4, and it is negative. Okay. So that's what we have here, is 3/4. So that is, we're subtracting 3/4. And we just have y on the left. So that is our inverse. And we will write f prime, or no, not f prime, thinking about something else. F to the negative 1 of x equals that, right? 3/2 x minus 3/4. Okay, so that's for examples. There are some things that come up in here that we don't do a lot of. So in solving these equations, things like what we just did here, we had to multiply by the reciprocal. So if you may forget how to do a few of these, just ask me in class, and I will help you out. That's all for now.